Auditory signals run from cochlea to cortex. The auditory center of the vestibular cochlear nerve is composed of approximately 30,000 to 50,000 auditory fibers on both sides of the head. Vestibulocochlear nerve is cranial nerve 8, which runs from the cochlea to the brainstem auditory. Afferent fibers carry message from the IHC, which are responsible for stimulating nerve fibers. Auditory neurons respond to specific frequencies. They have a best frequency that they respond best to. The tuning curve is a graph of the responses of a single auditory nerve fiber or neuron to sounds that vary in frequency and intensity. Auditory fibers do not respond to only one frequency. Cochlear nuclei are brainstem nuclei that receive input from auditory hair cells and send output to the superior olivary complex. Auditory nerve fibers divide into two branches upon entering the brainstem, then travels to one of the two groups of neurons, either the dorsal cochlear nucleus or the ventral cochlear nucleus, and the output goes various ways. The superior olivary nuclei are brainstem nuclei that receive input from both right and left cochlear nuclei and provide the first binaural analysis of auditory info. Inferior colliculi are paired gray matter structures of the dorsal midbrain that receive auditory info. The medial geniculate nuclei are nuclei in the thalamus that receive input from inferior colliculi and send output to the auditory cortex. These pathways extend to auditory cortical areas. The neuronal response is frequency sensitive. Tonotopic organization is a major organizational feature in auditory systems in which neurons are arranged as an orderly map of stimulus frequency, with cells responsive to high frequencies located at a distance from those responsive to low frequencies. It begins with the cochlea, and there is an orderly map from low to high frequencies, which is easy to see with 2-deoxyglucose. The primary auditory cortex, or A1, is the region of superior temporal cortex in which auditory processing occurs. It has to do with sounds, and it is activated then. It is found on the upper surface of temporal lobes. Pitch information is encoded in two complementary ways. Minimal discriminable frequency difference, the smallest change in frequency that can be detected reliably between two tones. Frequency is the physical property of sounds, while pitch is the subjective sensory experience of sounds, and changes in pitch do not parallel changes in frequency. Place coding is the encoding of sound frequency as a function of the location on the basilar membrane that is most stimulated by that sound. Treble is an aspect of pitch corresponding to the subjective experience of high-frequency sounds. Musical sounds and cymbals are an example of treble. Bass is an aspect of pitch corresponding to the subjective experience of low-frequency sounds. An example of this would be the bass guitar in musical sounds. Temporal coding is the encoding of sound frequency in terms of the number of action potentials per second produced by an auditory nerve. This is most effective in the low end of the hearing range. To be phase locked means firing occurs at a specific point in the cycle and directly affects frequency. It averages across several cells. The frequency properties of sound are coded in two ways: the distribution of excitation and the temporal pattern of discharge. Infrasound is low frequency sound, very low, in general below the threshold for human hearing at about 20 Hz. Ultrasound is a high frequency sound, in general above the threshold for human hearing at about 20,000 Hz. Brainstem auditory systems are specialized for localizing sounds. Binaural means two ears. Cues for locating the source of sound in the horizontal plane are intensity differences and latency differences. Intensity differences are perceived differences in loudness between two ears, which can be used to localize a sound source. These include sound shadow, which prevents sounds on one side, and off-axis sounds reaching both ears with equal loudness. Latency differences are differences between the two ears and the time of the arrival of a sound, which can be employed by the nervous system to localize sound sources. This includes onset disparity, which is different hearing at the beginning of sounds, and ongoing phase disparity, which is continuous different hearing. The duplex theory is a theory that we localize sound by combining information about intensity differences and latency differences between the two ears. The coincidence detector is a device that senses the co-occurrence of two events. Superior olivary nucleus is important for sound localization. Two main divisions are the lateral superior olive, which processes intensity differences, and the medial superior olive, which processes latency differences. Spectral filtering is an alteration of the amplitude of some but not all frequencies in a sound. The auditory cortex processes complex sounds. Auditory cortex geared for complex, biologically relevant sounds. In cortex, two streams of auditory processing occurs. The dorsal stream, which is the spatial location of sounds, and the ventral stream, which is the components of sounds. In auditory cortex, there is a bigger response toward things we do well or practice every day. Heschel's gyrus is a portion of primary auditory cortex where music is first processed. Amusia is a disorder characterized by the inability to discern tunes accurately. It's also known as tone deaf. And it shows that we are born with some music sense. Amusia results in fewer connections between the frontal cortex and the temporal auditory cortex. These people cannot process pitch. Diffusion tensor imaging, or DTI, is a modified form of the MRI in which the diffusion of water is a confined space and is exploited to produce images of axonal fiber tracts. Hearing loss is a major disorder of the nervous system. Hearing loss is decreased sensitivity to sound in varying degrees. Deafness is hearing loss so profound that speech perception is lost. Usually affects speech. Three main reasons for hearing loss: conduction deafness, sensorineural deafness, and central deafness. Conduction deafness is a hearing impairment that is associated with the pathology of the external ear or middle ear cavities. Sensorineural deafness is a hearing impairment that originates from the cochlear or auditory nerve lesions, and central deafness is related to lesions in auditory pathways and centers. Mutations can also be responsible for hearing loss, as well as loud noises over time, which can affect the cochlea. Streptomycin was a medicine that was found to have ear-damaging or ototoxic properties.